And now, please welcome Erin Silva.
Thank you. And thank you all for having me on this cold in Wisconsin Saturday morning with snow too. So it's going to be a cold shoveling experience this afternoon for me. I see several familiar names as I scroll through the workshop attendees, which is awesome. And hello to all of you familiar faces out there. I am going to be talking with you all today about intensifying cover crops and organic grain systems through interseeding. So a lot of this is from the research that we've been doing within my research extension program focused on organic grain production at UW-Madison. We've been doing this work for the past 15 years or so. So we've been really getting some good experience in organic grain systems and how to use cover crops for different ecosystem services like providing nitrogen and reducing the reliance on cultivation for weed management. And I'm going to be touching on that today. I see joining us is Leah Verek, who is now at the Rodale Institute as a consultant, worked for me for several years, and she was instrumental in a lot of this research. So Leah is just a wonderful resource out there as part of the Rodale Institute. And Leah, if I'm misrepresenting anything, please comment. I also want to note that I'll be joining the Ohio State folks at 2 o'clock to just hang out in their booth. So if there's any outstanding questions, or if you want to talk further about any of this, please join me with the Ohio State folks at 2 o'clock this afternoon. So why are we focusing so much on cover crops? Like I mentioned, a lot of my program focuses on reducing tillage in organic systems and reducing soil disturbance overall with cultivation as well. And oftentimes when we hear criticism of organic agriculture and where there's remaining deficits of agriculture, or why conventional farmers may not want to transition to organic agriculture, often it's focused on the degree of tillage, and that conventional systems have achieved no-till practices successfully, and without the ability to create a zero-till system, it really leaves organic systems wanting. But even though I focus a lot of my efforts on organic no-till, I really like to take a step back and focus on the 5 soil health principles. So certainly when I look at conventional no-till systems that are focused on corn or corn bean rotations, or sometimes honestly just simply corn as a monoculture, they often are very reliant, if not completely reliant, on herbicides, on GMO crops, and really don't focus at all on cover crops. And there's obviously a spectrum in terms of how farmers are implementing these practices. So I don't want to completely vilify or nullify the impacts of conventional no-till systems, but they don't integrate the 5 soil health principles, and instead really just focus on principle 2. But if we're really looking at building healthy, resilient soils, we need to focus on all 5. So soil armor, minimizing soil disturbance. And I want to emphasize that minimizing does not necessarily mean eliminating. There's studies in terms of long-term no-till systems that show that occasional soil disturbance does not necessarily set back our soil health goals with respect to aggregate stability and soil biology and the other aspects that we're measuring with respect to tracking how we're progressing with our improvement of our soils. Plant diversity, continuing living plants and roots in the soil and on the field, and then livestock integration. So simply focusing on no-till is not going to get us where we need to get to with respect to, again, creating healthy, resilient soils. But what cover crops allow us to do is to really, especially in organic systems, find a place for all of these, creating a soil armor. So with organic roller crimper systems, or even just with respect to having residues on the soil, certainly get to that achieving that principle, minimizing soil disturbance, again, through roller crimper systems or some of the other innovative ways that we'll be talking about integrating cover crops, plant diversity. So really going beyond just simply putting rye into the rotation after harvesting a cash crop, but really focusing how to create diverse cover crop systems, continuing living plant roots. So those overwintering cover crops are really vital here. And then cover crops allow us for another way to do livestock integration, especially through these interseeding systems, to be able to put livestock on after the cash crop is harvested and do some grazing. And it doesn't necessarily have to be your own animals. And again, I don't want to dismiss the complexities and the issues with fencing and water, but in areas where there are dairy systems, we certainly can look at bringing heifers from other operations onto the field for grazing, or again, other innovative ways of diversified livestock systems, which again is kind of another level of management, obviously, both with respect to in-field management and marketing, but can be achieved. So why interseeding? And that's where I'm going to start. And a lot of it, I think everything that I'm going to touch upon it can be thought of as some way of interseeding. And at least in Wisconsin, and I'm not as familiar with Ohio. So with everything I talk about today, I just want to make sure everyone takes it with a bit of a grain of salt and realizes that I'm very much talking from a Wisconsin perspective. I do think that sharing ideas across organic and just the type of farmers that tend to be involved in organic are very innovative farmers, and certainly hearing what others are doing in other regions, we can take that and think about how to adapt it onto our own operations that's appropriate for our crop rotations and crop sequences and our environmental conditions. But again, I would just emphasize that a lot of this would have to potentially be adapted to the Ohio region. Versus taking straight what we're doing here in Wisconsin. But in Wisconsin, we have a fairly short growing season. So with our organic grain systems, at least when we're talking about corn and soybeans, we're typically trying to plant a bit later. We're planting in May. We're not necessarily harvesting those crops till late September, early October. So there's a fairly limited window in those phases of the crop rotation to establish cover crops. I mean, oftentimes we're really limited to cereal rye as the option, which does offer, certainly ecosystem services, but not necessarily the whole suite of services that we'd hope to achieve. So the cost of establishment as compared to the benefits gained from those later planted cover crops is a concern. And if we're planting, I do realize, and certainly have experienced myself, that cereal rye, you could plant it into December. Heck, you would probably even plant it in January if it was the temperatures were above 0 and the ground wasn't frozen. Even could potentially spin it onto frozen ground, and it still might come up. But are we really gaining what we want to gain there with those couple inches of growth? I mean, that would certainly help potentially with some surface erosion, but in terms of really fostering soil biology and sequestering nitrogen and nutrient cycling, is that really getting us where we want to get? Even though the crop, yes, does germinate, but is it doing what we want it to do? So I just want to, as we first talk about interseeding corn, just show this cartoon here of corn growth and what are some of the critical phases. And what I want to emphasize here are the V0 to V5 stage. So when the corn is just starting to emerge, to when it's at its V5 stage, which for us probably is typically around the beginning of July here. So these are the phases that you'd think this is when you're cultivating. This is when you're getting out, you're doing your tine weeding, your rotary hoeing, your row cultivation. In between about the V5 and the V8 stage, that's when you're going to get canopy closure, so you don't have to do any more weed control. But also, I just want to emphasize that these are the critical times for weed control. So this is when, and I'm sure you've all experienced this, that if you don't get the weeds controlled at this time, then you're going to have significant impacts on corn yields. After this, to a certain extent, corn can take some weed pressure. Certainly in organic farming, we know that we don't need completely weed-free fields to achieve satisfactory yields. I mean, that certainly doesn't mean, sorry for that, but we don't want to get weed-free or minimize weed pressure in the field, not only for the impacts of that given season, but for minimizing weed seed rain. But this stage right here is really where that competition is going to be most impactful. So when we talk about early interseeding, this is really kind of the stage that we're looking at focusing on, is seeding those cover crops at V4 and to V6 stage. I mean, the thought was that this is when we are going to, again, be able to get another crop established, but be able to not cause competition with the corn. So this is essentially seeding at the weed-free period, after the critical weed-free period. And this was how this was approached as well as in conventional systems. But in organic, the other benefit here again is that, after that V5 stage, that's when canopy is closing and we're not typically doing cultivation anymore because the corn is more competitive with the weeds in terms of shading. So if we're interseeding at that time, we can interseed at last cultivation. So what cover crop species are typically used from our research, and Penn State has also done a lot of research with respect to interseeding, both in conventional organic systems. Red clover and annual ryegrass are the strongest performers. What we're really needing here are a few different traits. We need cover crops that are going to establish quickly. We need cover crops that are able to withstand a fair degree of shade. And we need cover crops that are pretty drought tolerant, because underneath that canopy, especially again in Wisconsin, where I'm coming from, typically in July, late July, early August, it's what's called our summer slump. And that's a drier period. I'll talk about, how that relates to interseeding systems in a bit, but we need something that's going to be able to withstand with pretty minimal root growth that drier period. Daikon radish has also been shown to work well. Radish, when we talk about cover cropping, we typically want to see that in a mix. Especially with a grass. It also works on its own, but again, if we're looking at kind of the longer term ecosystem benefits, and especially what that relates to for the next season in terms of soil stability, we want to put that in a mix. Other cereal species such as rye, and that should be triticale, not titicale, but triticale, and wheat have not persisted well. So if we're looking at trying to do this as a way to get those overwintering cereal grains established and get a jump on a planting date for those have not persisted well in this shaded environment that I just described. So in terms of how to try to manage for these interseeding systems, this has been a challenge because what we found is that, and this is again, it translates also to the conditions on the East Coast, but there are some nuances here that again might make Ohio differently. And you guys may have experienced things, and certainly I hope to talk about your guys' experience with interseeding into corn at the V5 or so stage. But earlier hybrids might be valuable because we are able to potentially harvest those earlier. And if we want to maximize then fall growth after we're able to open up that canopy in the field, that might be beneficial. Also, as we're looking at the types of corn that we're growing, silage systems may be more beneficial because we're really removing all the biomass on the field. So we're not putting that stover back on the field to smother that cover crop. So as we're, again, looking at systems where this is most appropriate, there's also an early harvest advantage when we're talking about silage systems. So that could work better. Moderate populations, what we're trying to manage for here is that balance of sunlight coming through the soil or the crop canopy, because if we're completely shading that environment, that cover crop may establish because there's enough sunlight coming through at the V5 stage that we're able to get that cover crop germinated, but there might not be enough sunlight to sustain that. So we've done some work trying to find a balance between plant population, plant growth, and I at the bottom of this list, upright leaf harvest hybrids, semi-flex hybrids, trying to figure out if there's a way to kind of moderate the amount of sunlight coming through the canopy, which again too relates to north-south row orientation. If we're really focusing on these systems, how can we create that balance of enough sunlight to support the cover crop growth, especially early on, because if we can get enough cover crop growth, that might shade out weeds without again, compromising our corn yields and our weed management overall, and then adequate end fertility as well. So this is our initial research tool, and I don't have any photographs of the more recent interseeder that we've been using, which is from Dawn equipment. So it's much more high tech than this. Again, Penn State has also developed some interseeders, but this was just a really super simple interseeder. So these are just some examples of some of what we've tried: interseeding red clover and daikon radish and cereal rye. We've also tried annual ryegrass. Typically, we're planting corn pretty late. This is later than we maybe would, but June 8th certainly isn't outside the realm of when we're planting. And then, like I mentioned, we're reaching that kind of V5 stage around early July, and that's when we're going through and interseeding. So doing all of our typical weed management on corn: tine weeding, rotary hoe, row cultivation, and then we're going through and doing some interseeding. So again, this was just kind of a really simplified model that was developed at our research station, where there essentially is just a small grain drill, and then there's certain row units and coulters removed to allow to pass over the corn. We did not find this to work particularly well because it did not get uniform pressure across the field, so we really had trouble getting good seed to soil contact with the cover crops. But just to kind of show what could be done, and potentially with more modifications, this may have worked better. But certainly, just with with a lot of our organic systems, we're looking at getting really good stands to get the functionality and the performance out of the crop that we want. That's certainly the case when we're talking about cover crops as well. So these are just some photographs of early on what we had been seeing. So you can see we still have some weeds here. Cultivation didn't pick them all out, but you can see this is a red clover cover crop between the corn rows. That's established. This is a little bit later on, but this is a good, nice picture from of a tillage radish within the corn crop. I do want to point out that this is the beginning of the row, and you might be able to see it, but as we go further in and there's a more dense canopy, and this is where the sunlight is able to get in at the end of the rows, this does diminish off. And this is I think this is cereal rye here, and it does start to establish well within the row, and you can see this is still early on. You can see the lights being able to come through the canopy here. And these are just a photograph too of that I picked up off of Pennsylvania of what this can look like. Now I want to just put in basically some summary of what we've found here. I don't have any data other than say that this with our, and Leah, you can type in and correct me if I'm wrong in the chat, but we did not find that any of the interseeding systems in these applications that we used impacted corn yield. What the biggest challenge for us has been is that this phenomenon that I saw dubbed by another research group that's even a little further north than we are in Madison, the vanishing cover crop phenomenon, where these cover crops can establish under the corn canopy, but they don't persist. And unlike, again, some of the research that we've seen out of the East Coast, particularly in the Midwest, what it seems, in talking to some fellow researchers as well, that where the variability of these cover crop systems stems from is the vigor of the corn. So if we get the corn growing too vigorously, which in our, kind of these corn belt systems, and particularly in the land that we're, working with on our mollisols at our research station, that there's just too much shading. And the times where we've seen this work is when we have less vigorous corn growth, which might happen on more, marginal lands where the yield potential is less. And in those cases, if we don't have as much canopy closure, then yes, these cover interseeding systems can definitely work without compromising corn yields. But it's very variable depending on, again, the vigor of the corn. And from what we've found, trying to alter plant population, so less plants per row, which then translates in a 30-inch row system, less plants per acre. And even with trying to modify through the variety, the stature of the corn to try to control for the amount of sunlight coming through the canopy, that even though we get these cover crops to establish, by the time we harvest in September, we really don't see that cover crop remaining. There's been times that we have, but there's been lots of times that we haven't. So in terms of, again, the benefit of these systems, does it justify the cost of the seed? Does it justify the cost of that extra pass over the field? Are we getting the ecosystem services that we need? I would say it's variable and it depends. So with any of these techniques that I would present to you today, I think it's something that you really need to evaluate on your own farm. I'm not familiar with the Ohio State research on this technique. But again, I can say that there's certain circumstances where this can work, including in more of a diversified mix. But it really depends on the year, and it depends on how vigorous your corn is growing and the potential yields of the corn and whatever site you're on. So with that in mind, I mean, one of the, and I think, other farmers have been seeing this too, as they've been trying to do this technique across the landscape, seeing that trying to fit this sort of system in a 30-inch row corn system, we're not getting the cover crop growth that we need. There's more and more farmers that are looking at moving on to more of a 60-inch corn system. So this has a couple different benefits, even without the cover cropping aspect. What the thought behind these systems is that corn, it's a C4 plant. It's going to really benefit from being able to capture as much sunlight as possible. And we just talked about how shaded those environments can be as related to cover crops. I mean, the thought with these 60-inch row systems as well, and you can see here in this photograph that the leaves are able to much more capture the sunlight and be able to get more of the potential of photosynthesis, being able to get more sunlight into the whole corn canopy. The other benefit of these systems is that, again, when we're looking at carbon or capturing the potential of sunlight, is that we're able to then manage between the rows with cover crops as well. So these are of interest in both conventional and organic systems. And the thought here as well, in terms of not compromising the yield by having corn essentially on every other row, if we're talking about 30 and 60-inch systems, is that we essentially double the planting rate within the row. So we're trying to keep the plant population per acre pretty standard, and instead planting more seeds per row. So in terms of the number of ears we're able to get for the field and the yield potential, we're going to keep that pretty simple. So this was a study that was designed by Leah Varek. So again, Leah, correct me if I'm not getting anything right here, but with a corn variety was an Albert Lee variety, and there were a few different populations chosen. So the control was our pretty standard 30-inch row. We go a little bit higher with our plant populations, 32,000 seeds per acre in organic. We even get up to 35 sometimes, but 32 is pretty standard here in Wisconsin. And then tried two populations at the 60-inch spacing. So not getting up quite to that same equivalent of 32,000 seeds per acre, but tried two at 20,000 and 28,000 seeds per acre, which essentially translated to in-row population of 40 and 56,000 seeds. If we're talking again, how that translates to, it's like double the not quite double, but almost like so there'd be like half the space between each plant in this 60-inch system. So we're kind of really packing in those plants. So what Leah chose to do within this experiment for the cover crop is to actually use a soybean variety. And the strategy here was that this wasn't looking at reducing tillage, nor reducing the cultivation passes. This was looking at trying to add diversity, trying to capture as much sunlight as possible, and potentially look at more of a proof of concept of how this might fit into a grazing system. So the soybeans weren't chosen to harvest the soybeans as grain. Instead, they were harvested or chosen more as a forage variety that we're going to get as much biomass as possible, as much carbon capture as possible, and as much shading as possible between the rows. So essentially what was done was that there was alternating corn on 60-inch rows, but then alternating soybeans on 60-inch rows. So the soybeans, again, were used as a cover crop in this situation. Went through, did the typical weed management, tine weeding, rotary hoeing, row cultivation, And from this 1 year's worth of data, so this was just tried last year, but it did look indeed that the 60-inch rows, we did see a trend, just slightly trending towards lower yields, but really quite competitive as well. So again, if we look at trying to understand too the value in terms of the other ecosystem benefits and trying to quantify what that might mean in terms of not only dollars if in the future part of the rotation, whether or not we could manage this to be grazed, or if there's another potential way to utilize this as a forage, or if it's looking at potentially nitrogen capture and fertility savings. This looks like it's a system of promise, and I'm really interested in continuing with this system and looking at what other options might be we able to do within this row, not necessarily forage soybeans, but are there other cover crops that we could use and potentially mixes that would also add benefits to pollinators or beneficials or nitrogen contribution for the following crop or other ecosystem services that mixtures provide. So stay tuned for more information there, but I was really quite excited to see the results of this research that Leah conducted this summer. So interseeding soybeans, I can't, I guess, give a talk without talking a little bit about roller crimping. Certainly this is not a roller crimping talk, but certainly roller crimping is a way to intensify cover crops through a way of interseeding. Although we're kind of flipping interseeding on its head here because we're actually interseeding the soybeans in this system. But this roller crimp system has worked extremely well at our research station in Wisconsin, and more farmers are starting to use it. And in this system, and this is a slide that I am graciously borrowing from Matt Ryan from Cornell University and his crew listed at the end here. I think it's just a beautiful schematic of what the practice is, where we're seeding cereal rye in the late summer. So the key here is to get it in by, sometime towards the middle part of September. Although I would say, and again, this is all environment dependent. In Ohio, I'm not exactly sure how that would translate, but we're planting it earlier than we typically would if we were coming in after a corn crop. We are coming in our experiments after an early maturing silage variety. So we're able to get that silage off ideally by early September and then come back round right away and plant that rye. But that's an absolutely essential step to get that rye in early enough. Rye overwinters, starts to grow again in May. We get a lot of biomass, easily reaches 6 foot tall, 10,000 pounds of biomass on the field. We mechanically terminate that when it reaches anthesis, plant the soybeans into that cereal rye. Soybeans emerge and we get that nice weed suppressive mulch. So it's been a really good system for us. Different equipment that can be used. I mean, I&J roller that was designed in collaboration with the Rodale Institute certainly is one that we see a lot on the landscape, but there's also other custom fabrications, and an increasing number of farmers are using this Dawn equipment where essentially these rollers are mounted on a planter. So it's a one-pass operation that way, where you get more also hydraulic control. And I've also heard too that this can be more effective on more uneven terrain where there can be a little bit more adjustment in terms of how much pressure you get across the field to facilitate rye termination. And I show this photograph, I think, in every talk just to emphasize the importance of planting that rye early enough. And this is a photograph that I've borrowed from Steve Mirsky and Bill Kern. Steve's with USDA. Bill Kern is retired from Penn State University, but both of them have done a lot of work here. All these photographs were taken on April 1st, but you can see the planting dates of the cereal rye across the top. And you can see if you plant late, just how much more of a thinner, sparser stand that you get in the spring, which is absolutely a critical time. And not only does this translate into the biomass that is rolled for a mulch, it also translates to early suppression of weeds as well. Because you can imagine if we're looking at common ragweed or some of those earlier emerging weeds, that's going to be coming up between the rye rows here. And those are going to continue to be a problem even after rolling, because if those weeds are already emerged, they are not going to be killed by the mulch. So we really need this thick stand early on in April to get the weed suppression we need. So you need to figure out a crop sequence if you're using this to get that rye planted early enough. We're running to roll an anthesis, which for us is late May, and that's going to allow us to get an effective termination. And if you go in too early, again, lots of these slides are borrowed from Matt Ryan, who's just done a lot of work in this system, both in Pennsylvania and in New York. You can see the rye regrowth, which is potentially going to be competitive with that soybean crop that given year, as well as cause issue with volunteer rye and subsequent years that could compromise other aspects of cereal grain production within that rotation because of contamination. So we want to make sure that we're patient and wait and use a heavier seeding rate of soybeans as well, up to 225,000 seeds per acre. And part of that is that weed suppressive canopy, and part of that is to try to make up for the fact that it can be hard to get good seed to soil contact and to get good stands in these systems. So this is getting to be a very crowded slide, but I do just want to show some of the yields that we've seen here in Wisconsin, which I'm quite proud of. And these are average yields across different experiments and treatments, but we've been doing this since about 2009. And the left-hand column here are our typical organic management. So a couple passes with a tine weeder, a couple passes with a rotary hoe, a couple passes with a row cultivator, versus our rolled crimped on the right. First couple years, we saw a bit more of a yield drag, and I really attribute that to us not exactly knowing how to manage the system well, so not planting rye early enough, not getting good equipment modifications. But as we were able to kind of dial in the system more and get the agronomics working more and the equipment working more for us, I think the yields have been very, very competitive, many times not significantly different. And in terms of what we're aiming for with yields in organic systems, these are excellent yields. I think if we look at our USDA reported yields on soybeans, it's more of an average of about 30 bushels per acre. So, but that's throughout the state. And we're probably in the prime growing region of the state. So again, I definitely want to take that with a grain of salt, but these are excellent soybean yields that any organic farmer would be happy with in Wisconsin. And these are some quick back of the envelope numbers that Leah has developed from our system using some 2008 and 2017, 2018 practices in terms of the profitability of these systems, comparing the different management in terms of passes across the field with plows and cultivators, cost of operating that equipment, cost of the cover crop seed, cost of the soybean seed, and then the yields. And what we find is that the cost is pretty comparable in terms of the input costs when you look at the cost of the cover crop seed versus the savings of going over with the cultivator. So that's kind of a wash. And where the biggest differences are is of course the yield. So we're looking at the profitability of these systems, the returns. The organic no-till system is about $740 per acre in this given year, and typical organic would be $765. But I do want to emphasize too, again, the other ecosystem services benefits that don't necessarily show up in this number, such as the additional carbon that's going back into the soil, the management aspects where, we're doing this as a research station. So we're really focusing on this versus on an organic farm. Having some acres under this sort of management might help spread out labor needs and equipment needs, where you have a lot of fields that need to be cultivated at the same time to get effective weed management. These would be just that, more number of acres that you wouldn't have to worry about getting out there and cultivating. And especially as we see wet weather and kind of challenges in terms of getting those timely mechanical weed management passes, this can help, spread out that workload and potentially reduce risk that way. So you have to kind of figure that into these numbers as well when you think about more of a holistic management approach and what that might mean for subsequent years and again soil building practices as well. So I want to talk briefly too about this other technique that we've been doing some research on in terms of spring planted rye. And this was inspired. This wasn't anything that we came up with, but it was inspired by a farmer, a long-term organic farmer, Jack Erisman, out of Central Illinois. So he's been coming to our conferences, and we had a field day early on one of his farms, and this was something that we saw in the field, and it was amazing how clean this field was. And this is all hinged on the concept that cereal rye, as a winter annual cereal grain, it needs to go through a process called vernalization to move from its vegetative stage into its reproductive stage. So vernalization means effectively that it needs to be exposed to low temperatures. And if we plant the cereal rye then where it doesn't experience these low temperatures in the spring, then it's going to stay vegetative. We'll show some photographs of that. So in these systems where we were doing these experiments, we were essentially planting rye and soybeans both in the spring. Interseeding them together, and rye at a rate of 2 bushel an acre, and soybeans again at that heavier rate of 225,000 seeds per acre. So the first year we did this, we were thinking, well, if we can get the rye in earlier, it's going to be more suppressive. So we tried to get the rye in as early as we could, like we typically would any other organic cereal grain that was planted in the spring, like a spring wheat or an oat crop. So we were drilling that rye on April 12th. There were some weeds coming through, so we tried tine weeding as a rescue treatment at May 10th, kind of going by that typical rule of thumb that we have to wait until we have about 3 flag leaves on that cereal grain before we can come in with a tine weeder, tine weeding pretty aggressively. Drilled the soybeans at a time we typically would plant soybeans, around May 26th. And what we found was that that was way too early to plant the cereal rye and not have it be susceptible to vernalization. It experienced cold temperatures, the minimum air temperature dipping below kind of the freezing temperatures, and we did see vernalized rye, which is not what we wanted to see in this system. So some photographs of what that rye looked like on May 10th. You can see all these little weeds coming through here, and as many of you that are familiar with tine weeding, these are already too big to really be controlled by tine weeding. This is some of the regrowth you see in the field, that the rye certainly was vernalized. And you can see on June 19th, we see more rye and less soybeans in here. So not what we wanted to see. And this is the rye regrowth. So this is not what we wanted to see with a nice, and this is certainly not what we saw at Jack Erisman's farm. So we did harvest this. We did get some soybeans in there, a really sad stand of 16,000 plants per acre, and a not optimal yield of 21 bushel an acre, but we did get something off of that field. But we were persistent and we wanted to try again. So we went and drilled the rye on May 8th. So waited a little bit later, but still trying to push that a little bit earlier and thinking, well, we'll get the rye up first and then plant the soybeans. You can see here, though, we still got a lot of those broadleaf weeds coming through. You can see, I think, some velvet leaf and some pigweed and some lamb's quarters. So by May 31st, we weren't going to be able to control these weeds. We knew we were going to have a weedy mess, or Leah did, because she's always the voice of reason in these decisions, and tilled that under on May 31st. But, some farmers we were working with did try this and saw success. So we were further propelled to keep working on this and tried it again in 2019 with some farmers advising us. So in this case, we did what our farmers were doing, because farmers are very, very good at understanding how to make the agronomics work in these systems. So we waited much later, and by doing a later planting, we were able to do some stale seed bedding. So those weeds we saw in the previous slide, we were able to get those already germinated, knock those down with some shallow cultivation, and then we did 2 plantings of the rye. So one planting was 5 days before soybeans, so really kind of shortening that window, and one was on the same day. And then we did a tine weeding of both that cereal rye crop and the soybean crop. These are some beautiful photographs that Leah took. This is what it looked like on June 12th. So nice stand of soybeans, beautiful soil. This is the cereal rye. You can see versus those earlier photographs, no weeds. This is what we want to see in a nice organic soybean field. These are another beautiful photograph of the field. You can see the rye and the soybeans on 30-inch rows. The rye here was drilled on 7.5-inch rows. That looks like our tine weeder going through the field. Beautiful field, very excited, doing what our farmers were doing to make this work. And this is what it looked like July 31st. So there are still some tine weeding passes. We did not rotary hoe. We did not row cultivate. So we did take out some of the soil disturbance here. And you can see this is what we wanted to see. And this is what Jack Erisman was seeing on his farm. You can see the soybeans, no sign of nutrient deficiency that I can see. This is typically what our soybeans would look like around July 31st. The cereal rye is growing vegetative. It's not, this is something else happening here. But you can see it's not vernalizing, it's staying vegetative. And this is another photograph of what that looks like. So again, the rye is starting to die back here. It's staying vegetative. It's not going to send up a seed head. This is what it looks like towards August. What it actually does is then die back down, and it forms this residue on the soil surface. So you can see on this photograph, and Leia's out here taking data with a quadrat here to measure biomass. We don't have a lot of weeds in there. You can see the soybeans, and then you can see that cereal rye just dying back. So this was beautiful. In terms of the weed biomass control, late planted is the soybeans that were planted a little bit later within some of our treatments, just demonstrating too that oftentimes later planting of organic crops, you get better weed control. And that's something that we're learning and always advising, that getting that first flush of weeds up and doing some stale seed bedding, you're going to get less weeds in organic systems, even if you're planting a little bit later. And there might be some balance there in terms of, again, kind of yield potential. But for the weed management aspects, lots of farmers are willing to compromise there. Rye planted the same day as soybeans, very little weeds. Wheat was another crop that was used. This is just emphasizes too, rye, there's definitely some allelopathy going on there, because whether it's in a rolled crimp system or some of these other systems, we always see rye having less weeds than the other cereal grains. With the rye planted a little bit earlier, did see some more weeds, but not significantly different as indicated by the same letters as we run the statistics. Control early. So that was the control soybeans that were planted a little bit earlier. More weeds, but not significantly so. Rye planted 5 days before, we did see more weeds, as indicated again by these different colored bars, even though we can't see the letters here. So very happy with the weed suppression. In terms of biomass, as we're talking about roller crimper systems, we're talking about 10,000 pounds of biomass from the rye. Here we're seeing more, about 1,500 pounds of biomass from the rye, but still seeing some biomass production that again kind of dies back and is then a killed mulch by the end of the season. And a little less than in the tire tracks, which is not surprising, because as we're rolling over there to do some tine weeding, we are damaging some of that rye. And then stand counts and yield. So the control soybeans planted earlier, even with the higher weed pressure, we did see a slight yield advantage, although not significantly so. But again, that's compromised with potentially some weed seed rain there in that system. But rye planted the same day in this system. So rye interseeded, we are eliminating some of those cultivation passes, yielded is significantly the same, 52 bushel an acre versus 54. We did see it a bit less, although again, not significantly so, 5 days late when the soybeans were planted 5 days later and the rye was planted 5 days before. But again, really encouraged by these systems, and the farmers that were trying this were really encouraged as well. But these are the 2019 data, and I think I saw Leah join again, and she could certainly chime in if there's time. But again, with a lot of what we're seeing with these interseeding cover crop systems is that this can be very variable. And this past year, we were seeing a lot more weed pressure. So again, another system where I would just, these are a bit riskier systems. I would be, if you were to try this, I would try this on a smaller scale on your farm. Just realize the risk, and also always realize that you may have to come in with a plan B, and that might be doing some cultivating, taking out that rye, but cultivating with the rye in there can be a challenge depending on the cultivation tool, but certainly could be an option. So just getting out there, again, starting small, assessing your system, always looking to see, do you have to go to a plan B or a C? But there are years where this system can work quite well. But what we found, and again, in partnership with farmers, is that doing some later planting, doing some stale seed bedding, and planting rye at the same time is probably the least risky of the ways to implement this system. Just a little bit with clover. So red clover is a good interseeding crop. And can provide quite a lot of nitrogen, total of up to 140 pounds of nitrogen when taking into account both the above ground and below ground growth. And certainly below ground growth can contribute a lot of nitrogen, which is often I'm asked in terms of, is there value in terms of like harvesting alfalfa and removing that biomass? Do you still get an N credit? Well, yeah, you do, because there's a lot of N that's within the underground structures as well, and underground biomass. And one of the easiest ways to interseed, and I was going to show this as a video, but I'm a little afraid I don't have some. Well, I'll show it as a video. So this is a barley crop, and this is taken this year. Let's see if I can show it as a video. Oh, maybe I can't. That's not working. Sorry about that. So it's a video, and what we do is one of the most tried and true methods of interseeding, you might be able to see it a little bit here in the front where my arrow is to, with winter seeded cereal grains, to come over and do frost seeding of about 12 pound an acre of red clover, and that red clover will germinate under that canopy. And I heard of a farmer on one of our workshops just this past season saying that they even go over the snow and will spread over red clover seed, and that red clover seed will establish under the canopy. And once you come in and combine that crop, it will just, open up that canopy. The red clover will take off, and you'll get a full lush field of red clover without any weeds in that field. And that is an excellent, easy way to do interseeding and to get that end benefit that I just demonstrated from the red clover. Interplanting is, again, kind of a different take on interseeding that we were trying to play around with. There's a farmer in Indiana who is speaking at one of our workshops coming up that has been trying to do this in organic systems. It has some beautiful photographs that he's often posting on different social media. Some farmers in Iowa are trying this. This is a field from Wisconsin that was taken at the Michael Fields Agricultural Institute. And what this system is trying to do, at least what I'll describe here that we had tried, is to do basically a co-planting of a cereal grain and a soybean crop. So the winter seeded cereal grain is planted as it typically would in the fall, whether it be rye or winter wheat, and then in the spring the soybeans are planted directly into that. And then the cereal grain continues to grow, and then the cereal grain's harvested and combined, and then again, the canopy's opened up and the soybeans can then grow. So you essentially get two crops and don't have to do any double or any weed management to the soybeans. So this field, this was several years ago that I saw this at Michael Fields. This is what it looked like. I believe it was in July. Here's another photograph of what it looked like in July. Now this was a wheat crop, and the challenge that was faced here was that with these dwarf wheat varieties, when the combine came through, it basically took off the top of the soybeans. So we lost some yield potential there on this, or they lost some yield potential there on the soybeans because of the lack of height differential between the soybeans and the winter wheat. But it did do, especially when you took into account that you were able to harvest two different crops pretty easily without having to separate the seed because you were combining them at different times. Even if we got a compromised yield on the soybean or a lower yield on the soybean, again, we're looking at the profitability and the productivity per acre, we're doing pretty well. And this was, again, no other weed management done to this field, and you were able to get two crops. But what was so Leah tried to do this at our Arlington experiment station, working with some of those farmers that had been doing this, but trying cereal rye instead of winter wheat. And that potentially would have been, again, a little bit more weed suppressive, as well as having more of that height differential that we needed to make this system work. But what happened, which is pretty typical with cereal rye, which we also experience with our roller crimper system, is you have a beautiful cereal rye cover crop. And then by the third week of May, we have a storm come through and it all lays down on the ground. And that's what happened in this case. So it just didn't look like it was going to give the soybeans a good shot to grow, as well as really be able to get that crop harvested, because by that time rye doesn't necessarily bounce back. So I still, again, would like to keep fooling around with this system, see how it might work. What are the best soybean varieties to choose and cereal grain varieties to choose? Are there taller winter wheat varieties or some of these other hybrid rye varieties that might have better standability in this system, but still might offer more of that height differential? I do think that this system can work, but we do need to look at, again, kind of optimizing those agronomics, just like we were trying to do with that spring planted cereal rye system. So O-Grain, I just want to extend an invitation out to participate in O-Grain. I know there, again, I recognize several names as I look through the participant list from attending our O-Grain workshops, and have been wonderful in terms of sharing what you guys are doing down there in Ohio. For any of these things that I talked about today, feel free to reach out for further information, shoot me an email. This should be, I don't know, apparently last night I did not, I must have shifted my finger over. We are hoping to have another winter conference, and there's been some Ohio folks that have made a road trip up for our winter conference, which was always been thrilled to see faces outside of Wisconsin. And we're still hoping that we canceled this year, but in our in-person event next year, 2022, this should say, will be the last weekend in January. And the other thing that you could participate in, which again, we have some Ohio farmers participating, is our listserv. And this farmers are often sharing information, asking questions to each other. It is national and even international. We have some Canadians on the listserv now. So again, always have to kind of take with a bit of a grain of salt in terms of what people are doing and how to adapt that to your region. But we also have on the listserv, we share resources and our events as well. So it's a Google group, so you can get a digest at the end of the week instead of being inundated with daily emails. But I'd highly encourage you to check us out there, as well as on Facebook and Twitter as well. You can Google or enter in O-Grain in the search and certainly find us. So with that, I think we have about 5 minutes for questions. And then again, I will be at the Ohio State booth this afternoon if you want to stop by and talk about any of these different things we've been trying, or always curious to hear your guys' experiences as well.
Thank you, Erin. It looks like we do have some questions in the chat, so I'll kind of go through those and read them off. It looks like earlier on we had a question about what about the use of 60-inch paired rows?
Yeah, that is definitely something we would like to try. I do think that there's even more potential with that system. And we were pretty simple with the way we approached this year, and COVID too made us have to be even more simple than we might have been. But I've been talking to our ag engineer about trying to figure out a way to do that next year. I'm really excited about looking at that as a potential modification as well.
Looks like we have another one here. Cover crop growth where corn is poor could potentially be a risk management practice for operations with grazing animals.
Yes, definitely. Yep. Exactly. Yeah. Yeah. And is it trying to weigh the risk? But I do think, particularly in grazing operations, and again, if we don't have as much corn growth, it's going to help that cover crop growth. But in weighing that with the cost of the seed and the extra pass over the field. But yeah, definitely agree with that comment.
Looks like there's a comment about Ohio State has been experimenting with interseeding at their research station, but nothing formal yet. Looks like the next question is, do the interseeded soybeans overwinter? No,
they didn't. And I don't know. And Leah, you can comment what happened after harvest if you remember, but they wouldn't have overwintered. But that's where, again, I'm really excited to try in that system. What we might be able, how we might be able to modify that potential, the cover crop choices or mixtures. I mean, as compared to these 60-inch row systems on conventional, we're going to be struggling with how to manage those weeds between the 60-inch rows without herbicides. So Can we get away with, doing mixtures and seeding rates of those mixtures that we can still do rotary hoe passes, but maybe can get away without cultivating? Are there ways to kind of, plant diverse cover crop mixes still on 30-inch rows with like alternating 60s that we can still do cultivation? I think there's just so much to try. It's always so frustrating that we only have so much land in only 1 year to try all these things, because there's so many things that you can think of to try. But yeah, I think that's looking at other options that might overwinter would be a really interesting, but the soybeans wouldn't have. And Leah made the comment that nothing was done to the field after harvest. So she doesn't know, or nothing, she doesn't know what the soybeans look like now. I imagine it would be just the residue would be completely gone.
Looks like we have another one here. Did you fertilize the rye at all?
No, we don't. We've tried several different ways of fertilizing the rye, both in the fall and in the spring. And Leah, correct me if I'm wrong if you've done other things in that field. Prior to Leah working with me, and again, Leah's with Rodale now, so I'd highly encourage to reach out to her as in her consulting role if you wanted to learn more about this as well through that service. But we're also working on really fertile soils at our Arlington Research Station. So I found that either with applying manure in the fall or spreading composted chicken manure in the spring to help with increase rye biomass, all it did was stimulate weeds. I can't say that wouldn't be a decent practice though if you were on less fertile soils, which again, and I'm not sure what the Ohio situation would be, but we're working on, our mollisols at our research station are more like Iowa. So they're like beautiful, beautiful soils. So we haven't done that, but I wouldn't necessarily say that wouldn't be beneficial in certain cases.
And then there was a question about what is a quack digger?
What is a quack digger? Gosh, what is a quack digger? To me, it looks like, oh gosh, what would you call it? With a tool. It's like a cultivator, but without big sweeps. And what do you call those cultivators? Is it like an S-tine cultivator where it's just kind of like a narrower, like 2-inch curve sweep? And what it does is, it's not looking at cutting up, it's an awesome tool. It's not cutting up the rhizomes of the quackgrass, but instead it acts like kind of a rake and drags it up onto the soil surface. So what we're trying to do is not cut them, but drag them so that when they're on the soil surface, they'll desiccate. And unfortunately, you have to do that a few times. So you may have to take the field out of production for a year. And obviously, in terms of soil health, not the best. But we've used it to try to clean up quack infested fields, and it does work quite well.
Looks like we have a couple more questions coming in. Have you tried interseeding crops other than soy into crimped rye, sunflowers, buckwheat, other forages?
Yeah, excellent question. And we just got a new grant with Cornell University to try some of that. And I'm really excited to kind of expand our application of that. I question what's going to be most appropriate to roller crimp into cereal rye. Soybeans, I haven't tried it, but I've heard of others that have done it. And sunflowers seem to be pretty, I don't know. I don't know if they're sensitive to the cover crop crimping in general or planting into that cover crop, or if it's specifically with the allelopathy in cereal rye, because soybeans don't seem to be affected by that allelopathy. So sunflowers I've heard have not worked, but we are trying to, with this new grant with Cornell, look at other roller crimped options to kind of expand the application of this. So doing winter wheat into sorghum Sudan grass or crimp buckwheat. We've been trying, and I didn't put this in this presentation, but other roller crimp crops for corn, which is a challenge for us, but might be more applicable in Ohio because of your longer growing season. So stay tuned for that. I do think that there's from Cornell some really promising results of how we might be able to expand this application, and that the key then is going to be figuring out crop sequences where we can kind of keep piggybacking these cover crops and cash crops to work together in a way that we're able to get the planting synchronized.
Do you know of anybody that has tried crimping rye and then following with a non-vernalized rye for a soybean crop? Double whammy on the
Yeah, I
weed
know. I've heard
control.
about that a lot, especially, and I don't know if oh gosh, I know. And Leah, chime in if you remember anyone that actually did do this that you've heard from. Like if we get our thin rye stand, can we kind of piggyback on these two techniques so we can get the extra weed suppression of that spring planted rye to make up for a thin rye stand for roller crimping where weeds might break through? I know I've heard farmers ask about that and say they were going to try it. We've never tried it. And I don't know if I've actually followed up with a farmer that has tried that, but I've heard of people talk about that. And Leah said she remembers a lot of people talking about it last winter, but I don't know of anyone that did it either. Yeah, I should ask on the listserv because yeah, there was definitely chatter about that, but I never heard of anyone that the follow-up if anyone did that.
It looks like we have another one about would fertilizing rye help if it's planted later?
Yeah, I do not think so. I think that early tillering, and this is and more as I work in this, even though it's been over 10 years, I have worked in that photograph I showed of it's not just the absolute biomass, and there's been some interesting work from Joel Groover as well. And again, Leah, I'll have you chime in if you have any other thoughts on this. But it's not only that absolute biomass, and that biomass we get by having both a high seeding rate, so about 2.5 bushel an acre, which I'm not so good at translating that into seeds per acre, but it really should be translated into seeds per acre because cereal rye can vary in terms of its seed size and weight. But say 2.5 bushels an acre as shorthand. So getting that rye seeded heavy enough and then getting it early enough. And some of what we see in terms of making this work is not absolute biomass of 8,000 to 10,000 pounds per acre at crimping, but again, is that photograph of getting that, really good stand that's covering the soil. And it seems like tillering is really essential for that. So I don't think fertilizing is a way to make up for especially that aspect, even if I just haven't seen the biomass be, and when I talk to farmers that have tried this and where the system hasn't worked, I always inevitably hear that they've planted late. I don't think it's as much of a fertility issue, but I haven't tried it, so I don't want to absolutely speak to that. More for that, I've heard of farmers asking for that early season suppression and that ground cover, is there a way to broadcast seed? Is there a way to we're doing it on 7.5 inch rows. Is there other seeding densities that we can try in terms of actually putting out the seed? Although I have to say and I know Cornell has tried this too, and maybe Penn State, where they're doing half of a rate drilling and half of a rate broadcasting. For this application where we're putting so many eggs into the cover crop basket in terms of our weed management that I just feel like broadcast seeding is too risky. And a lot of what I hear about this is you have to start treating your cover crop like a cash crop, and that includes kind of making sure you're optimizing your stand. I just don't. I just worry about broadcasting. It can work, but you need to make sure you get a good catch and everything lines up well with rains and establishment and stuff. So.
And then do you have Eastern giant ragweed issues?
I don't know if it's Eastern giant ragweed. We have a lot of giant ragweed issues though in organic, and it's probably, now I'm hearing more about water hemp being the next big weed in organic. But yeah, giant ragweed, I'm not sure again if it's different than Eastern giant ragweed. We just had a workshop yesterday, a grain workshop about electric weed zapping, and that, it's really looking like, especially with soybeans, that is a great tool. And rolled rye is, I think, a really great tool with giant ragweed as well. And then having cereal grains in the rotation. So there are ways to mitigate it. And yeah, especially with this weed zapper tool, that's really effective against at least whatever giant ragweed species we have, which I can't say for sure is Eastern, but helps a lot there.
It looks like there's a comment about a growth regulator for organic that works well to get the rye to catch late rye to catch up. And it looks like that might be it for the questions.
That's interesting. I hadn't heard about the growth regulator. All right. Yeah. If you want to come chat, just come at 2:00 and visit me at the booth Ohio State booth.
Well, thank you, Erin. We appreciate your time, and we thank you, everyone, for attending the session.
All right. Have a great rest of the conference, everybody.
Thank
Bye.
you.